Hello, I am Matias Edu, a 5-year-old student at Chemistry Specialty at Horta Almagro campus in Argentina. First of all, I would like to let you know that I have serious thoughts on which subject to prepare for this presentation on science. But as you can see, I have chosen to talk about the solar system. I didn't choose this subject because I consider myself a star, but because my family told me that I could do a great job to take all the planets alive. I had to admit, it wasn't easy. It was hard to do it, since, as my parents say, I was always in the moon. Anyway, let's do a quick summary on what we know about the solar system. It has one sun, obviously, and it has 8 planets. Okay, ready? Let's start! Mercury. It is the closest planet to the sun. Mercury has no protection against the sun, and because of that, it is burned and reduced. The nucleus is very big in relation to its surface. There is a theory that says that when the planets were formed, one crashed against Mercury, and a big part of it blew away. Mercury has plenty of scars. They induce reminiscences of impacts of asteroids. Venus. Known by the Romans as the goddess of love, this planet is beautiful, since it's all covered by yellowish clouds that are very attractive to the view. But what are the clouds made of in our planet? Our clouds are made by the accumulation of water being evaporated by the heat of the sun. And in Venus, the clouds in Venus are made by sulfuric acid. This prevents the light and the heat of the sun to reach it, and on top, this is the second one closest to the sun. Below this layer of deadly clouds lies the real Venus, and you could think, well, since the light of the sun doesn't reach it, wouldn't it be colder? But no! In Venus, the temperatures can reach up to 500 degrees Celsius. That's because on its surface there are more than 1,000 active volcanoes. And not being that enough, the pressure is greater than on Earth, and the entire atmosphere is composed by carbon dioxide. Now, this is the real Venus. Beautiful, isn't it? Mars. For centuries, we looked for life there. It is the planet that most entrained gas. It's proven that that great red ball was like the Earth before, full of water and vegetation, full of life. But it has been billions of years since it is inert, a fossil. It doesn't have an atmosphere, and the air there is almost all composed by carbon dioxide. Also, it may not look like Mars has water. There is water there, but not this water, or this water. No, I'm talking about this water. Mars has frozen water on its poles. And you know what else Mars has? Mars has the Mount Olympus, but I'm not talking about the one from the Greek gods. I am referring to the largest volcano in the solar system. It is 3 times larger than Mount Everest, and it is inactive. Or it seems to be inactive. There is a possibility that there is life below the surface of Mars. There is also another possible theory that says that in the time Mars was alive, an asteroid hit Mars, sending part of it in direction to the Earth. As a consequence, we are all descendants of Mars. Wait. But don't worry, it's just a theory. Okay, these were the rocky planets. So let's move to the gaseous ones. Jupiter is the largest planet in the solar system. Jupiter is almost all gas. We will drown if we just step on it. Saturn is composed completely of gas. Its characteristic rings are as long as the distance from the Earth to the Moon, and they are a few hundred meters deep. Uranus also has rings, but these have a special feature. They are in vertical. It is 60 times the mass of the Earth, and it's composed by toxic gases. Neptune is composed of methane gas, and there is so much wind in it that it has created a tornado from the size of the Earth. It has a lot of gravity. Now I'm going to name a former planet that is very small. Yes, I am speaking about Pluto. Pluto has the characteristics of being very cold. It is considered a ball of ice rather than a planet. The highest temperature reached there is from 218 degrees below zero. And there is still one more, the planet Eris. I'm not going to talk much about it. I will only mention that it is 130 billion of kilometers away from the Sun, and that it takes 10,000 of years to go around the Sun. Well, we talk about the planets in the solar system, but we are missing something essential. The Sun. It is 150 kilometers away from the Earth. It is so far away that it takes like 8 minutes to reach the Earth. The Sun has so much mass that with the force of gravity it controls the entire solar system. But what our eyes see at first glance is not how it looks really. The Sun is actually this. Yeah, it's not as pretty as you thought, right? The Sun is a huge sea of incandescent gas. It rises 5,500 degrees Celsius in its outer layer. At its core, it reaches 15.5 million degrees Celsius. Do you know why the Sun is hot? It's because it has atoms of hydrogens to merge together to form helium atoms. These reactions makes heat and light. But the hydrogen atoms are not infinite, and someday will end. On that day will begin the death of our Sun. It was calculated that the Sun's life will be of 12 billion years, and right now the Sun is at the half of its life. Now the Sun is at 30% brighter than when it was born. When the hydrogen in its core will end, our Sun will begin the red giant phase. It is a process by which a star goes through when it's near to its death. Little by little, it will begin to expand, and it will increase its mass for 100 times. And then, it will begin to shrink until reaching the size of the Earth. At that time, the Sun will have become in a white dwarf. And you may ask, why doesn't it explode and become a supernova? Well, that's because our Sun is a medium-sized star, which doesn't have enough mass to become a supernova. Well, I have already said all that I wanted to say, but I won't let you go without giving you something to think in your way back home. Think of how an ant sees us. Imagine if a molecule had life. How would it see us? Now think how an atom will see us. And now think how a neutron will see us. We are huge compared to any of these examples. Now think that you are that neutron. But we are not looking at a person. No. We are looking at the universe. Because this is what we are. We are a subatomic particle within the cosmos. Thank you.